What is the difference between distance and displacement? Do you know the difference? Well, there's a big difference between the two, and it's important to understand it. The reason it's important to understand is that these two words come up all the time in the study of kinematics. So, in order to understand this, let's just take a look at some examples. Let's first of all take a look at some examples of distance. Let's suppose that you start at point X. We'll call that point X. That, by the way, has a name. That starting point has a name. It's called the origin. And we're going to start at the origin, point X, and we're going to ride a bike or some other mode of transportation all the way over here to point Y, and we're going to stop at point Y. If I were to ask you what is the distance that you traveled, you might have measured the distance and you might say, well, between point X and point Y, I know I traveled 10 kilometers. And that is the distance between point X and point Y, 10 kilometers. Well, 10 kilometers, that is a scalar measurement. So the first thing you want to remember about distances is that distance is a scalar measurement. It does not have a direction. Distance does not have a direction. It's a scalar measurement. And it is simply the length of the path traveled between the origin, your starting point, and your ending point, in this case at point Y. So I could say here that the distance I traveled was simply 10 kilometers. Well, let's take a look at another situation. Let's suppose again you started at point X, our origin, and you traveled all the way to point Y, right there. Then you turned around and you came halfway back and stopped right there. We'll call that point Z. If you stop here at point Z, the distance that you traveled, the total distance that you traveled, was 10 kilometers to Y and 5 kilometers halfway back to X. Z places you at a total distance of 15 kilometers. Why? Because that is the total length of the path that you traveled between the origin and your final destination, which was point Z. So the distance you traveled was 15 kilometers. Now let's take a look at a third situation. Let's suppose that you started at point X again and you traveled all the way over here to point Y. Now that was a total, remember, of 10 kilometers. And then you turned around and you came all the way back home again to point X, to your origin. And that trip gave you a total of 20 kilometers round trip. The distance that you traveled was equal to 20 kilometers, the round trip distance. Okay, let me throw another situation at you. What if you started here at point X and you walked through the woods on this path, which was very curvy, very convoluted, it wasn't a straight path, and you came all the way back here to your origin right there at point X. You came right back home again. Now if you measured the length of that path around all these curves right through the woods here, you might find out that the total distance that you traveled was perhaps 20 kilometers, whatever it was. Distance, by definition, simply put, a simple definition, distance is the total length of the path that you travel from your origin to your final destination or stopping point. It is the total length of the path traveled. That's distance. And distance is a scalar measurement. Going back to the previous lesson, remember that distance is a scalar measurement because it has a quantity and a unit of measurement. That's all it has. That makes it a scalar measurement. So distance, here's what you want to remember, is the total length of the path traveled from the origin to the ending point, and it is a scalar measurement. Now let's take a look at displacement. And we'll use the same scenario each time. So in the first scenario, we started at our origin, which was point X, and we traveled all the way over to point Y. And that was a distance of 10 kilometers. But the displacement is not just 10 kilometers. The displacement in this case is 10 kilometers east. Displacement, unlike distance, is a vector measurement. It is a vector measurement. And that's important. It is a vector measurement because it not only includes a quantity and a unit of measurement, but it also includes a direction, in this case east. And you'll notice right over here I have a small compass rose over here. It shows you north is towards the top of this page, south is towards the bottom, east is to the right, and west is to the left. So displacement will always include either a stated direction or an assumed direction. So if I said somebody has a displacement of 10 kilometers, then you have to just assume, even though I didn't tell you what it was, that there's a direction there somewhere. So let's take a look at some other situations. This first situation, the displacement was 10 kilometers east. In the second situation, we started at X and we traveled all the way over here to Y. Then we turned around and we came halfway back. Now, if we look at the distance is a total of 15 kilometers. But the displacement, when you reach this point, point Z, right here, when you reach point Z, your displacement is not 15 kilometers. Your displacement is equal to 5 kilometers east. And you might say, well, why is that so? Well, it's the real difference between distance and displacement. Your displacement is the straight line distance and direction between the origin, your starting point, and your ending point. So this red line represents your displacement, and that displacement is 5 kilometers east of the origin where you started. That is really the difference between distance and displacement. Distance is simply the length of the path that you traveled, where displacement is the straight line distance and direction between the origin and your final ending point. So let's take a look at this third example down here. We started at X and we traveled all the way to point Y, and then we turned around and we came all the way back home again to our original origin. And when we did that, the distance we traveled over here on the left, the distance we traveled was a total of 20 kilometers. That would be from X to Y is 10 kilometers, and from Y to X back again is another 10 kilometers. So the distance was 20 kilometers. However, our displacement is now 0. Why is it 0? It's because we are back at the original point and we are not displaced from that origin. Displacement, going back to the definition, is the straight line distance and direction between the starting point, the origin, and the ending point. And the straight line distance and direction between the starting point and the same point where you end is now going to be 0. So the displacement is 0 in this situation. Alright, let's take a look at this next example down here. We walked this curved path. And I won't redraw this path, but let's take a look at this. if we look at the distance that we traveled along this curved path over here, we traveled a total distance of, I said, 20 kilometers. But since we came all the way back to the original origin, our original starting point, the displacement is equal to 0. Why is it 0? Because displacement is the straight line distance and direction between the starting point and the ending point. Another way to say this is displacement is how far you are displaced from the origin. How far and in what direction you are displaced from the origin. So in the first situation up here, let's take a look at these three. In this first situation, your displacement is 10 kilometers east because you are displaced 10 kilometers east of the origin. In the second scenario, you are displaced 5 kilometers east of the origin. And in the third situation down here, because you came all the way back to your original starting point, your origin, then you are displaced 0 kilometers from your origin. And that is the difference between distance and displacement. Distance is a scalar. Displacement is a vector measurement. Why? Because a vector measurement, like displacement, has both a magnitude and a direction. Displacement is how far you are displaced from that origin. It is the straight line distance and direction between the origin, your starting point, and your final destination. And that is the difference between distance and displacement. All right, now we'll take a few minutes. We'll see if you understand what we're talking about here, the difference between distance and displacement. Here's a situation I'm going to give you, and then I'm going to ask you a couple of questions about it. If you start right here at point X, there you are, and you walk 20 meters over here to point Y, and then you turn south and you walk 10 meters down to point 0, and then you turn and walk 20 meters west towards point Q, and you stop right there. Your origin is at X and your final destination is at Q. My question for you is, in this trip, what is your distance and what is your displacement? Go ahead and figure out what each of these are. Stop the video, solve the problem, then turn the video back on, and I'll go over this with you and see if you got it right. So go ahead and pause the video now. Alright, now that you're back, let's go ahead and solve this. The distance that this person traveled, remember, is the total length of the path traveled. That would be 20 meters plus 10 meters, which gives you 30 meters, and then 20 more meters, which is a total of 50 meters. So the distance this person traveled would be 50 meters. Now, what is this person's displacement? Remembering, of course, that displacement is the straight line distance and direction between your starting point and your ending point. Another way to say that, remember, displacement is how far and in what direction you are displaced from your starting point. And that is represented by this line right here. This would be your displacement. And your displacement in this situation looks to be just about 10 meters south. In other words, you are displaced 10 meters south of your starting point, of your origin. And so, there are the two answers: distance 50 meters and displacement 10 meters south.